Hi, my name is Eduardo. I'm a PhD student at Mackenzie University in São Paulo, Brazil. This study is about ionospheric irregularities during the last solar cycle in the South American sector. The irregularities are those regions of the ionosphere with higher or lower electron densities. These irregularities provoke scintillations, which are changes in the amplitude or phase of radio signals, especially in GNSS communication. The aim of this study is to make a full mapping of the scintillation during the solar cycle 24 in the South America. The solar cycle 24 was the last solar cycle that ended last year. And we are using S4 index that gives the amplitude scintillation. This is important because if we know the locations and when the scintillation happened in a certain region, we'll be able to predict how it will behave in the future cycles and also to predict when and where GNSS obstruction is likely to occur. These are the stations we are using, some of them at the north, some at the south, and some at the magnetic equator. And this is the solar cycle 24. It started in 2009, reached the maximum activity in 2014, and ended in 2019. The amplitude scintillation, S4, is calculated by the standard deviation of the power of the signal over 1 minute. The values of the power first pass through a low-pass filter to obtain the intensity trend, and then it's normalized by 60 seconds, average to obtain the power detrended. The values of S4 are also verticalized, considering the elevation angles from the satellites and using the altitude of the ionospheric piercing point. We use the cutoff angle of 30 degrees, and then we calculate the percentage of times S4 is greater than 0.2. This is the plot of 2009. The map goes from January to December, and from deep angles 40 to -40. And the brightness indicates the percentage of occurrence of the S4 greater than 0.2. We can notice that in 2009, which was the solar minimum, the scintillation was very weak. Then, as the solar activity increases, we can see an increase of the scintillation. So this is 2010, 11, 12, 13, and 14. This is the peak of the solar activity, which corresponds to the peak of the scintillation. There are some interesting things here. First, the scintillation follows the equatorial ionospheric anomaly, as we can see an enhancement of the scintillation in the northern and southern crest of the fountain effect. We also see an asymmetry between north and south. This is because the magnetic equator line is not straight in the South America. And also, the scintillation occurrence starting in September equinox increases even more in the December solstice, which is summer in the South Hemisphere, and continues all the way to the March equinox. This is in agreement with the previous works we related in our study, and the main reason of that is that plasma bubbles usually appears in the summer hemisphere after the sunset. After that, the scintillation decreases again as the solar cycle decreases. So this is 2015, 16, 17, 18, and 19, which is the end of solar cycle 24. Our main conclusions. There are higher S4 index during the maximum solar maximum and during the spring and summer at the south hemisphere, higher occurrence of S4 at the southern and northern crest of the equatorial ionospheric anomaly, lower occurrence at the magnetic equator, and asymmetry between south and north, more intense at the south due to the magnetic equator inclination over the South America. Thank you.